So continuing with complex numbers, remember when we are working with these things, the I is treated exactly like any other letter that we use, X being the most one that we use, but the rules around it are exactly the same unless we end up with I squared and then it automatically equals -1. We replace the I squared with -1. But other than that, all the other rules are exactly the same. So I'm going to take the 6i here and distribute it to each of these things inside. So 6i times 4 gives me 24i, and 6i times 3i gives me plus 18i squared. So what I do now is 24i plus 18 times -1. Always replace the I squared with -1 and put the -1 in parentheses so that we don't screw anything up. And people like to just see the I squared and just automatically try and do something without actually replacing it. And almost always we get signs mixed up that way. If you actually replace it and put it in here, you most likely won't have trouble with that. So now I've got 24i squared. And then positive 18 times -1 gives me -18. But this answer is not correct because remember, for it to be a correct answer, I have to put the real part first and then the imaginary part. So if you give me this as an answer, 24i minus 18, you will get it wrong. You must give it to me as -18 plus 24i, the real part first, and then the imaginary part. So let's just keep working on some examples here. 6 minus 4i times the quantity 2 plus 4i. Well, I'm just going to FOIL this. So 6 times 2 is 12, and 6 times 4i is 24i, and -4i times 2 is -8i, and -4i times 4i is -16i squared. Now, these two middle terms are like terms, so I keep the I part and then add the two numbers. So that's an addition problem whose signs are different. So I subtract the small number from the big number and keep the sign of the big number. And then I'm going to do this with a 16. And then I squared becomes -1. And so now I've got 12 plus 16i. -16 times -1 gives me positive 16. Now these two, the 12 and the 16, are like terms, and so I combine those two, and that gives me 28 plus 16i. Again, real part first, imaginary part second. Okay, let's do another one. 3 plus 2i times the quantity 3 plus 4i. Okay, so 3 times 3 is 9, 3 times 4i is 12i, 2i times 3 is 6i, and 2i times 4i is 8i squared. Again, my 12i and my 6i are like terms, and then plus 8 times -1. So 9 plus 18i, -8 times, positive 8 times -1 is -8. And then 9 minus 8 is 1, and 18i. Now, take a look at this one. 4 plus 7i times the quantity 4 minus 7i. Take a look. I hope each of you, the first thing you said was, oh, difference of squares. Because they keep coming up everywhere, guys. I've said from day one, got it. Well, from the moment we started with the rule 2, the special factoring forms, you've got to learn these back and forth because they come up everywhere. So remember, when we're multiplying these out, it ends up being x squared minus y squared. So the 4 is my x and the 7i is my y. So I take the 4 and square it, that's 16, minus, because in a difference of squares, it's always minus. And then I take the 7i and square it. Well, that's 7i squared. Well, that's 7i times 7i. Well, that is 49i squared. So now I'm going to go 16 minus 49 times negative 1, because I squared equals negative 1. Okay, and so now 16 and negative 49 times negative 1 gives me positive 49. And so 49 and 16 is 65, and that's my answer. Okay, how about this one? 5 minus 2i, the quantity squared. I hope you all realize that this is a perfect square trinomial. 2 times x times y plus y squared. So the 5 is my x, the 2i is my y. So first thing, take my x and square it. So 5 squared minus, because this sign always determines this one. And then my middle term is take my x and my y, so I multiply those two together. That's 5 times 2i is 10i, and then multiply it by the 2, so that becomes 20i. And then positive, because in a perfect square trinomial, the second sign is always positive. Then I take my y and square it, and so that becomes 4i squared. Now I do 20i plus 4 times negative 1. Again, without doing this, you've got a good chance of getting your signs wrong. Okay, minus 20i, negative 4 times, positive 4 times negative 1 gives me negative 4. Now I combine these two, and I end up with 21 minus 20i. Again, make sure real part first, then imaginary part. Okay, so as I've said before, we've got to always watch for these patterns, difference of squares and perfect square trinomial. They come up everywhere, and they're going to keep coming up. Okay, so now what we're going to do is called conjugate, or conjugating the denominator. So just like earlier in the unit, where we had to rationalize the denominator, meaning we had to get rid of the radical sign in the denominator, here we have to get rid of any i's that we have in the denominator. So in our final answer, we cannot have a radical sign in the denominator, and we cannot have an I in the denominator. Okay, in this case, if it's with an I, it's called conjugating instead of rationalizing. So rationalize, they mean the same thing. It's just that rationalizing goes with the radical sign and conjugating goes with the I. Not that that's that important, as long as you know you have to get rid of the radical sign or the I in the denominator. So here's the thing. If we have, to begin with, a binomial in the denominator, okay, then we need to multiply, just like when we're rationalizing the denominator, we need to multiply that denominator by whatever will make it be a difference of squares. So binomial in the denominator multiply by difference of squares. Whatever will make it be a difference of squares. So that's why, again, why it's so important that you recognize and understand what difference of squares are. And of course, if I multiply that in my denominator, I have to multiply the exact same thing in my numerator. Okay? Now it's just a matter of foiling out the numerator. So that's 24 plus 18i plus 8i plus 6i squared. And the denominator is a difference of squares, so I just take my x and square it. So 4 squared is 16. In a difference of squares, that's always minus, and then I take my y and square that. So 3i squared is 9i squared. Now in the numerator, I have the 18i and the 8i. Those are like terms. So when I combine those, that gives me 26i. And this is 6 times negative 1 in my denominator now. And again, you see how I'm working each numerator and denominator separately, but I keep the problem together so I don't lose its continuity. And 9 times negative 1. Okay, so in my denominator now I have 24 plus 26i minus 6. And in my denominator, I have 16 plus 9. And so now in my numerator, I have 18 plus 26i. And in my denominator, I have 25. Now let's take just a moment and pretend, I don't like the way that looked, pretend that we ended up with 18 plus 26i over 30, and this was a correct answer. It was right. We got it right. Well, it feels like I ought to be able to cross-cancel the 30 and the 18 and the 30 and the 26, but you cannot, because the only time you can cross-cancel is when the things are being multiplied and our numerator is being added. So let's think about factoring. Well, I can get a 2 out of each thing in my numerator. And now I can cross cancel the 2 and the 30. And so my final answer for this is 9 plus 13i over 15. Okay, so really watch when you've got something like this where you can cross cancel. You need to do that. Otherwise, it's not in lowest, simplest form. And last but not least, if I am conjugating or doing this when I only have an I in my denominator, then I need to multiply that I by whatever is opposite. So only I, or negative I, in the denominator multiply by the opposite I. So if you have a negative I, you're multiplying by a positive I. If you have a positive I, by a negative I. And whatever you do in the denominator, you have to do in the numerator. Okay? So once again now, I'm just going to distribute this guy to both of these. So I get negative 5i plus I squared. Negative times a negative is a positive. And then in my denominator, negative times a positive is a negative, and I squared. So negative 5i plus negative 1, again, so I don't mess anything up, and negative times negative 1. And again, I'm just trying, all of this is just to get rid of everything in my denominator, or in i's in my denominator. And so now I have a 1 in my denominator. I don't need anything else in the denominator. That can go away. But I do need to rewrite this so I have real part first and imaginary part second. And that, guys, is the end of Unit 3.